In this video, I'm going to talk through 2D arrays. We're familiar with 1D arrays, and the way that we like to visualize a 1D array is as a series of cubbies, right? Where each cubby illustrates an element in the array, and each element has an index starting from 0. So this would be element index 0, index 1, and index 2. And let's say this were an array of integers. We know that we could store integers in them like 1, 34, 67. We can place whatever values we want in each element of the array. So a 2D array then is a lot like a 1D array, but each element stores another array within it, right? So you can think of this kind of like a grid, but in reality, the way that we like to think about this is we've got a regular array, and within each element is another array, right? So we might be at index 0, 1, 2, which refers to the outermost array. And then once we've addressed a particular index, we're working at one of these inside arrays, or the second dimension of the array. So this would be 0, 1, 2. And so if we wanted to access, say, the element in this particular cubby, we would use an index of 1, which refers to the outermost array, and then an index of 2, which refers to this element right here, and that's how we would address something within a 2D array. So let's take a look at how this actually works in code. Right? So I'm going to pull up some examples here, and we're going to begin by declaring a 2D array of integers. And our 2D array will look something like this. We'll call it array A by a simple convention. All right, so this is us declaring a 2D array, and notice that it looks a lot like a 1D array, except that we have this second set of square brackets. And that second set of square brackets is what gives away that we're working with a 2D array of integers, all right? And we can work with a 2D array of objects of other types like doubles, strings, so on and so forth. The way that we initialize a 2D array is a lot like how you would initialize a 1D array, except we have to give a dimension for the second array size as well. So let's say we wanted to make an array that was, we'll do this 2 different sizes, 3 by 2. And I forgot the new keyword. So every time you initialize a new integer array or a new array of any kind, you have to use the new keyword, and it's followed by the type. And then in square brackets, we give the dimensions, or how many elements the first dimension of our array is going to hold and the second dimension of our array. And so when this runs, what would actually happen here is that Java is reserving some memory where our outermost array with a size of 3 is allocating 3 cubbies, right? 0, 1, 2 being its indices. And then each of those elements has another array within it with 2 elements in it with indices 0, 1, 0, 1, and 0, 1, all right? And so what we're about to see when we go to assign is we can say something like A sub 0 sub 0 is assigned 3. And the way that this works is we're going to look at the outer array first and see that that maps to there. Then we're going to look at the inner array element and see that that index corresponds to this one and assign 3 to that particular cubby. All right, so let's give that a shot. So we can now say assign to A sub 0, 0 a value of 3. And that would assign that particular element in our 2D array a value of 3. We could do the same with A sub 0, 1 and a value of 4, say. We could go to the second index. So remember, our outermost array has a length of 3. That means its maximum index is 2, and assign a value there. So after we've made these assignments, we could read from these elements as well. And so we could read from them by just referencing them like we would any other variable. So we do system.out.println and say A sub to 0. And we're going to read the value at index 2 sub index 0. And we'll see that if I run this, 5 gets printed out as we would expect. Right? And so a 2D array is a lot like a 1D array where every element is actually another array embedded within it. sometimes it's actually easiest to think of this just like a grid, right? So once you understand that this is an array with arrays within it, it becomes easier to think about this just as a simple grid where we've got on the outermost edge 0, 1, 2, and the inside elements or the other axis we've got just 0 and 1 as our axes. And so this will, if we're thinking about this in terms of a picture or a photo, we can imagine that this is our y-axis and this is our x-axis. And so when we assigned a sub 2, 0, we're looking at x of 2, that's this one here, y of 0, that's this one here, and we know that we are going to be filling this value in with 5, all right? And so that element's value is now 5. And so you don't have to think about this as an array within arrays when you draw this out visually each time. It's oftentimes easier to think about it just as a grid, a 2D grid. And the way that we read these values is by addressing them just like a 1D array, but we have that other index on there as well. So how do we find out how long one of these, how many elements are in a 2D array? Well, we can ask either dimension. We can figure out how many elements are in the outermost array of x by asking for a.length, and we'll try that in just a second. And then because each of these elements, each of x's elements are actually, an array within it, so a0 is another array, we can say a sub 0's length. Let's actually give this a shot. So if we want to find the length of the first dimension of an array, we can just say system.out.println a.length, right? And when we run this, we'll see that 3, which corresponds to our outermost size of the array, right? So this is the number of elements in the outermost dimension, or we might think of this as the x dimension, right? And in the second dimension, what we can do is we can just ask one of these elements, like a sub 0, how many elements do you have? And what this will give us back is the elements in the y dimension, right? So a sub 0 gives us 2, which is the number of elements in the y dimension. So knowing these two things, we can write for loops that will work through every single element in this array, item by item, right? So let's try that out. Why don't we try making a multiplication table, right? So one of the things we could do is we could say for int x assign 0, because our array indices always start from 0, while x is less than a.length, which is the number of elements in our x dimension. We're going to increment x by 1 each time. And we'll do the same with y. And here we can say y is less than a sub, we could hard code 0. A best practice is to use the actual column that you're working with. And we'll say x instead of 0, or you could use 0. Either way is fine. Length, y++. All right. And let's assign to array index x, y, a value of x times y. So we're going to make a multiplication table. All right. And so if we think about what's happening here, the way this works is we've got a grid here, right? And here's our 2D array. I'm going to draw it with the sub-elements. All right, and let me label these indices real quick, 0, 1, 2, and this is x, and then 0, 1, and this is y. And above we assign some things. Since we're going to overwrite each of these values, I'm going to ignore what we had assigned before, but there, at this point in our program, there would have been some values here. And so what we do in this outermost for loop is we set up a variable x and give it an initial value of 0, and we set up a value of y, also giving it an initial value of 0 as we come into that loop, right? So the way that we think about this is int x is assigned 0, 0 is less than a.length, a.length is 3, so that's true. We come into this loop and we reach int y, we declare y to have an initial value of 0, 0 is less than ax, so ax is this particular array with two elements in it, right? So that particular array, the question is, how long is it? It has two elements, so a.length is 2, 0 less than 2 is true, so we get down to this statement. And here what we're saying is we're assigning a of x, which is 0, and y, which is 0, so x 0, y 0. This particular element right here, we are assigning x times y, which is 0, right? And we're done with that loop. We're going to increment y. So y's value is now 1, right? And 1 is less than 2, that's true. So now we are going to assign to a of x 0, y 1. So this particular element here, we're going to do x times y, 0 times 1 is 0. So this is getting to be a little bit silly on this column, and we can kind of get that that the row up top is going to all be zeros as well. But let's keep moving through this. So we've reached the end of this loop because y becomes 2. 2 less than 2 is false, so we're done with this innermost loop, and we increment x by 1. And then 1 less than 3 is true, so we come to this innermost loop, and now y is back to 0, right? So now we're working on the second, or the 1 index of x, and 1 is less than 2 is true. So what we're going to say is a of 1, which is this particular x value, y of 0, so we're talking about this particular element right here, is going to be assigned 1 times 0, which is 0. And we're done with that, so we increment y by 1, y's new value is 1, 1 less than 2 is true, 0, a sub 0, sorry, a of 1, so this is our x, and 1 is our y. 1 times 1 is 1, so this particular value would be filled in with a value of 1. And now x is incremented to 2. 2 less than the length of that, which is 2, is false. So we're done with this loop. We increment x again. X is now 2. 2 less than 3 is true, so we come to this inner for loop for the final time because we're working with this last x column. And now what we say is y is 0, so y's value is 0. 0 less than 2 is true. And now we're going to say array at index 2 on the x-axis and 0 on the y-axis is being assigned 2 times 0, which is 0. And we increment y to be 1. y 1 less than 2 is true. So we're going to say assign to x2, y1, a value of 2 times 1, which is 2. And you can see that we're making a multiplication table here. And just to be complete, we'll go back to the top. Y's value is 2. 2 less than 2 is false. Remember, we're looking at how many elements this particular array has in it. That's 2. That's false. So we increment x. X is now 3. 3 less than 3, that's also false, so we're done. And this is the final state of our 2D array after this inner nested for loop is completed. And so this is the pattern that you'll see for working with a 2D array. You'll have a nested loop where each loop is going to be working through one dimension at a time. So the inner loop here is working through the y dimension, and the outer loop is working through the x. We could flip these, and if we did that, rather than working like this, where we start on the outside and we work down y because the inner loop is y, and then come back to the top, instead, if we worked through the loop where y was the outermost loop and x was the innermost loop, we would work through the 2D array with a pattern that looked like that. All right. So the last thing we'll do is let's try printing these out. So if we write another for loop, I could say for int x is 0, x less than a dot length. So we're going to use the exact same looping mechanism. For int y is 0, y is less than a sub x dot length, y plus plus. And now we will just do system.out.print a of x, y concatenated with an empty space. And then I'm going to print out at the end of each line. So remember, we're going to be working through column, and what we're going to see is that this is going to actually print out not quite in the imagine that we would visualize it. So I want to give you an example of if we start with x and then our inner loop prints out with y, we see that it's 0, 0, 0, 1, 0, 2. So we're traversing the array in the same way, but because we're working through each y value in the inner loop, the shape of this and the coordinates of this don't match the way that we sort of imagine it, right? So we want our x to be printed out in full before moving on to the next row. So just like I mentioned before, the way that we want to do that is we can flip the way that we traverse these axes. Right, so here I'm going to say for y, while y is less than a sub 0 dot length, and we'll just use the first row, that's perfectly fine, and for the first column, y plus plus, and instead we're going to iterate on the inner loop over the x-axis, and here we'll want to use the outermost dimension as our bound. We'll change our counter variable, and so we've flipped the order in which we are doing the nesting of the loops, and now we should get something that looks like what we would expect, what we drew out. So here we're getting 3 values on the x-axis and 3 values on the y-axis. And again, the reason for this, let me just leave this open for a second, is if we think about our 2D grid here, right? So here's our x-axis, here's our y-axis, y and x. And if we start with x, what it means is if x is in the outermost loop and y is in the innermost loop, we're going to start with one value of x and then go through every y that's in the nested loop before we move on to the next x, and then move through every y before we move to the next x, and then move through every y, right? Whereas if the way that we write our loops is we have y in the outermost loop and x in the innermost loop, we are going to start at this y, and then on the inner loop, because it must complete in its entirety before we move to the next iteration of the outer loop, is we're going to move through each value in our x-axis before coming back and moving through the next y value. Right? And so the order in which you arrange the loops will determine the directions in which you move through each element in your 2D array. So that's it for 2D arrays. They're a lot like 1D arrays, but you've got that extra dimension. We'll be going over this in class on Tuesday.